In this video, we are going to build on our knowledge from the previous one, how to run an HTTP4s server with Smithy4s, and we are going to run a client this time. So we will start from the point where we ended the last video. We have a running HTTP4s server using the Smithy4s spec, and let's look at what steps we need to take to get from this to a client that can call a service built with this. So this is our code so far. Let's just do a quick recap of how we can call it. We just call it using HTTP or curl or a browser if you have a get. Actually, we can try to open the get endpoint in a browser as well. Let me just take this. So these are the Smithy4s docs, and this is our site. So in Firefox, this is the default rendering, but the raw data looks like this. We have just a JSON object. So that's pretty cool. You can also code from a browser, but of course, this is not what we are here for. We're here for a client in Scala in HTTP4s. So first I'm going to rename this main class to server main. We're going to stay in the same file just to, sorry, of course it's not a class, it's an object, but you see what I'm saying. We are going to use the same file just to avoid like doing the same imports over and over. But of course, you are free to structure this in any way you like. I'm going to have a client, client main, and again, this is going to be an IO app, a simple IO app. And my idea for this object, this app, is going to be that when we run this will perform these two requests in a sequence. It will first create a city and then query the weather for it. So that should show us that we are able to both decode the response and then take the output of that and send it as an input to the next operation. Because when we create a city, we will get a city ID back, and then we can send this as an input to get weather. Let's look at how we can get a client. First, we need something, again, in the server, we needed something that can bind to HTTP and serve our routes. Here it's going to be sort of different. What we did before was we got things generated from Smithy4s and we gave them to the server. Now we need to get a client and give that to Smithy4s so that it can give us something like a weather service. But first we need this runner of requests, which is basically a client, and I'm going to use Ember client for this. By the way, hopefully I don't need to state this, but because Smithy4s doesn't actually integrate with Ember, but with HTTP4s in general, you can use any kind of server, any kind of client, as long as it accepts this HTTP routes type. Or if it accepts HTTP app, then you're set. You can use that. So yeah, we will need to build this client, Ember client builder. That's again the magic incantation. I'm going to just build this and use it. So this is our Ember client, this C. Now, yeah, what do we do with it? So I mentioned before that we need to give it to Smithy4s, and we can actually use the same simple JSON builder interface, except now we cannot call routes because we don't have an implementation. We want an implementation to be built by Smithy4s from this weather service type. And it's actually as easy as it sounds. We can say weather service dot client, and here we have to pass this HTTP1st client, this C. So far it compiles, and now I can say build. Sorry, the names here are different. We should unify that, but to avoid confusion, let's just use resource. This is going to be essentially the same thing as here. We get a resource with this nasty weather service gen type, which, if you remember from the previous video, is what weather service actually is. So maybe we are onto something. So we have this resource. I'm going to use that again. At this point, you could refactor this use into a flat map and then use. I'm not going to do that. But this is our typed client. And let's see what it is. It's a weather service gen, but what methods does it have? It has these two methods. So it's exactly the same type actually. Like client is a weather service of IO, the same type that our implementation was. And we got this from nowhere. We wrote no business logic, no HTTP bindings, nothing like that whatsoever. We just get a weather service, which is really great. because now I can say create city, London, UK. I can flat map on this with an output, and that's a create city output. So I have a city ID here according to our spec. That's correct. I can take this city ID and pass it to get weather, and now we have an issue. It expects IO of unit because we are in an IO of unit. I'm just going to print that. And because of monad laws, I can do this. It should be the same thing. Yeah, let's see how that works. First, we need to have the server running, of course, but I'm going to rerun it because there should be now 2 main classes. That's going to be server main. And in another tab, I'm going to run the client again in SBT and try to connect to that service. And this is going to be client main. And it works. We just got this output here. And you can see in the logs of the server that it's being called by the client, not these lines, this is about SBT, but we are seeing these print lines from my implementation right here. And let me run that again. Yeah, it just works. So yeah, I think this is very cool. And what is really important, let's try to maybe take this and put it right next to our implementation. We don't have a client from Ember, which is kind of sad. Let me take the whole thing again. Okay. And the type of this is, okay, this is IO of unit, but if we stop right here and flat map, this is going to be a resource of something nasty. Even Metals doesn't handle this. But we can simplify this type into weather service of IO. And yeah, this is exactly the same type. And because it's the same type, we could even like combine these two things to have something like a proxy, have a server that calls the client, like uses the client to call another server. We could do this. It would be just a matter of like enough flat maps. Basically, instead of impl, you would pass. Actually, let's do this. So we have this this client resource, flat map, impl. Sorry, this has to go here. Yeah, this is it. This is exactly it. Now we don't have the server implementation. It's not used. And when you call this server, it will try to call another server on the same port. I think it would actually be a loop right now, but we're not going to try that. However, you could tell the client to use a different base URL because it just happens to use the default, which is localhost 8080. Of course, I should tell you that. You can customize this by setting the URI here, and then you pass like any Prerequisites URI, which I think I need an import for. Yeah, so you can customize this, use any other port. So this right here will be sort of like a typed proxy of just the requests documented here to an upstream service at port 9090. I think that's really nice that we are able to combine these things in this way, but you probably don't want to do this. Like that seems like a very specific use case. One more thing I wanted to show you was, yeah, we can also use this client inside. Let's say this is the client, implementation client. We can combine all these things if we just restructure our code a little bit so that when our server starts, we can have this client resource. So we do have a client resource. We can have the client call some sort of method like city ID. So now we will start the server and then do something like a smoke test on it, basically. In server main, we'll start the server and then immediately call it with a sort of anonymous client, except the client still lives. We could even be smarter about the address, because right now the client will just call the localhost 8080 port every time. We could make this instead parameterized with the URI, and then we override the URI. And then we have to shuffle our code a bit again because we need the URI, but it's only available here in the when we get the server binding. So something like client resource, server binding base URI, and now use get weather. Let me reorganize this a little bit. Yeah, so here's what's happening. We're starting a server at some port. This is just going to use the defaults from Ember. And then when we have the server running, we print its address, and we also use this address, the base URI of the server, as the baseline for requests in the client. And we use that to build a client and send one request, the get weather request. Then we are done with the use, we shut down the client, but we keep the server running. So let me run that again. Yeah, so it works and the server keeps running. We can actually, again, call it. But just to show what I mean by this usage of the base URI, we can change the default, the host or the port of Ember. We just have to import Comcast IP4s. And host is going to be even 0000, which is basically localhost. And the port can be something else. Just to be very explicit. And when I run this again, I don't have to change anything on my client because it uses the binding from the server, whatever it's going to be. So that call was made here. And we can just add like another print line to showcase this as well. And yeah, we have the output right here. So this is it. I hope this was useful. As you can see, once you have the Smithy4s HTTP4s library, and once you have used the simple REST.json builder, getting a client seems much easier because you don't have to implement any business logic. You just call a bunch of methods. You get an Ember client, which you probably already have if you're using Ember, and you pass it to the builder. You get a resource with the nicely typed weather service, and now you can just call methods on it. So you don't have to decode any JSON bodies. You don't have to parse any HTTP headers or anything like that. I think it's very nice, very type safe, and very cool. So this is it for this video. I hope you enjoyed this, and I'll see you in the next one.